Hi, welcome back. So today we'll continue on with the second part of P2 P3 algebra. Essentially, last week we discussed how to find solutions for some absolute value function or some modulus functions. So there are two ways. One is to squaring both sides and then find the solutions. The other way is to just apply the plus or minus, and then after you solve the whole equation, you check your answer. So for these two methods, essentially it's better if you use the algebraic method. It's better that you check your answer because sometimes without sketching the graph, you don't really know whether you got the correct solution or not. Alright. So in this video, we will look at how we plot the graph and then solve some inequality equations. So for instance, so let's just look at the example. So let's say you have this particular modulus function, modulus x minus 4. So essentially what the modulus function tells you in terms of the meaning is that the output of the function should not have a negative value. So usually when you plot these particular modulus functions, you would want to check when the equation inside the modulus hits your x-axis. So when x equals to 4, x minus 4 is basically 0. So you know that this particular line hits your x-axis at 4, 0. And then you just need another 2 points for you to plot the graph. For example, when your x equals to 0, y will be equals to 4. When your x is, let's say, 8, y will also equals to 4. So why do you need 3 points? So essentially when you plot the graph, let's plot it here. So you know that your graph actually hits the x-axis at here. X equals to 4. So this is 1 point. Then what you need is 2 other points. So for example over here, so one is on the left of this particular point, and then another one is on the right of this point. So then you can just draw a straight line linking these two together. So that will be your modulus function. So the step for plotting your modulus function is essentially the first one, identify your x-intercepts and then find 1 point on the left of your x-intercept and then another point right of your x-intercepts. Then you can essentially sketch the graph. So that's what I did. So if you want to plot y equals to 2x plus 1 as well, so I will demonstrate to you why sometimes you only have one equations, sometimes you have two equations. So let's say I want to sketch 2x plus 1 onto the same graph. So I can substitute x equals to 0 inside, y will be 1. So for a straight line, you just need 2 points. So let's say I substitute x equals to 0 and 1, then I get y equals to 1 and 3. So 0, you get 1. And then when it is 1, you get 3. So it will be over here. So this will be the straight line passing through. Let's move the line a bit around. So this will be the straight line passing through these 2 points. So as you can see, y equals to 2x plus 1. This is y equals to modulus x minus 4. As you can see, the straight line 2x plus 1 only intercepts at your modulus point at 1 point. This particular line cannot intercept to this line again because it diverges. So when you, for example, when you try to solve using, so let's say when you try to solve by algebraic means, so one of the methods is to separate out the positive part and negative part. So here x will be equals to minus 5. So the negative portion will be minus x plus 4 equals to 2x plus 1. So x will be 1. Okay? So as you can see, you have 2 solutions, but you know that one of the solution is not the answer because when you check your answer, so minus 5 minus 4 is 9. The right side is 2 times minus 5 plus 1, which is minus 9. So the left side is plus 9, the right side is minus 9. So what does this mean? This means that this is not a solution. And from the diagram perspective, so let's put it here, all my calculations. From a diagram perspective, you actually try to intercept the other lines over here. So this is the second intersection points, but this line is not true. It doesn't satisfy the equations, which is why you have to reject x equals to minus 5. So that's the reason why sometimes you only have one solutions and you need to check your answer when you solve for modulus equations. So this is the explanation for it. So let's move it back here. So let's try to draw some more complicated modulus equation. Let me write down properly. So let's say you have y equals to 1 minus modulus x plus 2. So now you can sort of use function transformation to actually plot the graph. Remember that previously we have something like this. So when a is a positive value bigger than 1, then it is a stretch in y direction by a factor of a. When it is a smaller value in between 0 and 1, which is still positive, then it is stretched in y direction by 1 over a. So for B, it is totally opposite in terms of x direction. So for C, it will be moving to the left when it is positive, and it moves to the right when it is negative. And then for D, it will be the up down movement, but also totally opposite from your x direction. So I will explain more on this if, let's say, in the future I go back to P1 on the function transformation chapter. But for now, what is important over here is to compare between the right side of the equation and the left side. So you know that for a modulus function, so let's say you have y equals to modulus x, the graph essentially looks like this. Okay. So what you need to do is to apply function transformation and then see how the end result looks like. So over here you have a minus sign. So this means that you need to reflect on your x-axis, and then you move up by 1 unit. So let's write down all the function transformation. So you need to reflect on your x-axis, and then you move up by 1 unit. The third action is to move to the left by 2 units. So the final graph will look like this. So this is minus 2, and then you have 1 over here. So this point, it will become like this. So of course this is just a rough sketch. 0 minus 1, yeah. Of course this is just a rough sketch. If you want a more accurate sketch, then what you need to find as above, as I demonstrated above, what you need to find is your x-intercept. So in this case, you can't really find your x-intercepts because it's being flipped over, and then you are being moved up or left, right. So in this case, what you can do is to understand that the highest point for this particular graph is when x equals to minus 2. So minus 2 plus 2 over here, it becomes 0. So then y will be 1 minus 2, which is 1. Sorry. What am I doing? Minus 2 plus 2. So this is just 1. So then you got the first point over here. Then you try to find 1 point to the left, somewhere around here, and 1 point to the right, somewhere around here. Then you should be able to plot this graph. So the most important thing for you every time when you start plotting the graph is to find the maximum or the minimum of your function, and then find 1 point to the left, of your maximum or minimum, and then this will be 2, this will be 3, 1 point to the right of your maximum or minimum. Alright, so essentially that's how you find That's how you sketch the graph. You can either do it by function transformation, or you can do it by identifying all the points. So it depends on how fast you can work things out. So let's look at one more example. So this is a bit interesting because the minus sign is inside the modulus function. By right, you should have reflection on your y-axis, but for this particular equation, you can also do it like this. So you have a minus sign, 2x minus 5, then put a modulus. Then you can separate out the modulus element. Wait, sorry. And it becomes modulus 2x minus 5 plus 3. So it means that for modulus equation, actually if you notice it, for quadratic equation as well, there is this left-right symmetry between the axis of symmetry, which is for y equals to modulus x case, your y-axis is your axis of symmetry. Because of this left-right symmetry, essentially you can factorize out the minus sign, and then it doesn't change anything. So if you just study this by function transformation, so what you would have is first thing, you so over here you there's actually more things that you can do. You can even factorize out, for example, the 2 outside. So then this is a not to say proper, but easier equation for you to study the function transformation, because then now this corresponds to A, this corresponds to C, this corresponds to D from the equation that I wrote over here. So for this, I will also copy it and then move it downwards. So once you identify all the variables or constants, then you can easily write down the transformation. So you have a stretch in y direction by a factor of 2, and then you move to the right by 5 divided by 2, which is 2.5, and then you move up by 3 units. So this particular graph should look like this. So the lowest point will be at 2.5, and then something like this. So this will correspond to 3. Alright, so that's how you would plot the graph. So finally, I would like to introduce a very specific example. You have a 2 modulus equation adding up together. So how do you plot this? Is easy, provided that you know exactly where is the lowest point for x plus 1 and where is the lowest point for x minus 1. So over here, the lowest point for x plus 1 is when x equals to minus 1. The whole function becomes 0. Whereas x minus 1, this is when x equals to 1. So if you look at the number line, so this is minus 1, this is 1. Okay? So when your x is less than -1, so both sides of the equation will be the minus part of the equation. So you have the minus part of the equation plus the minus part of the equation. When it is between -1 and 1, so you have a positive part of the equation plus with the negative part of the equation. And then finally, when it is larger than 1, you have the positive part of the equation add with the positive part of the equation. So then you can break this down into 3 portions. So the first part is the negative part of the first part, and then sum with the negative part of second equations. So this happens when x is smaller than -1. Second portion is between -1 and 1. So you have the positive part and then minus the negative part. So this happens when x is between -1 and 1. Then the last one is the positive part sum with the negative part. So you have greater or equals to 1. So what will be this set of equation looks like? First one is -2x, second one is 2, third one is 2x. So over here then you can sort of plot the graph to look like this. So let's say this is -1, this is 1. You have this whole portion at 2, and then the left part is -2x, the right part is +2x. So that's how you plot this type of functions. Alright. So now let's look at the next section on inequality. Perhaps I should frame it better. Solving inequality. So there's nothing much special. Sorry. What you need to take note is that whenever you see modulus of some function or values, modulus of a, for instance, is smaller or equals or smaller than b, then what it really means is a is between -b to p. So you might wonder, how is this the case? So remember, modulus x can be broken down into the positive part and the negative part. Positive part will be this. Negative part will be -a smaller or equals to b, or a is greater or equals to -b. So when you combine together, remember that it means essentially the above. Okay. So when you have modulus a greater or equals to b, for instance, it means a has to be smaller or equals to -b, and a has to be greater or equals to b. So you can use the same approach that I did, finding the positive part. So this is the positive part, and then the negative part, and you would get to the same answer. So you just need to remember these 2 points. So probably I will just put it on the right side. And then do it like this, so that you can see how it connects to each other. So let's look at some examples. So when can you actually use this? When, let's say, you have modulus 2x minus 5 is smaller or equals to or smaller a constant, let's say 2, then you can directly break it down like this and solve the equation. But if you don't have this kind of form, the left side and the right side are sort of like equations. So for instance, you have x minus 2. So I wouldn't advise you to try to do that, because it will just leave you with mistakes. Of course, we for this particular example, I will show you both methods. The third method will be for you to use graphical methods. So I wouldn't discuss the graphical methods, because essentially you just plot graph and then identify all the points that your straight line x minus 2 will intersect with modulus 2x minus 5, and then identify which region the inequality stays true. So you can easily just do all this by yourself. But what I will stress over here is how do you use the algebraic method. So if I were to do this, what you can do is, let's test it out. So I use the first property. So then you have 2 minus x smaller or equals to 2x minus 5 smaller or equals to x minus 2. Okay, so over here is actually a bit difficult for you to work out the x. It's actually not that difficult. Okay, perhaps I will just show it like this. But in reality, it's better that you break this particular equation into two inequality like this and then solve it. But for this particular question, no, I don't think you can do that either. Yeah, you can't do that. So it's better to break it down into two inequality. So let's break it down into these two inequality. So you have 2 minus x smaller or equals to 2x minus 5. So then I move the x to the right hand side, the number to the left hand side. So I have 7 smaller or equals to 3x, or x is greater or equals to 7 divided by 3. So that's the first one. Second one is 2x minus 5 smaller or equals to x minus 2. So x will be smaller or equals to 5 minus 2 is 3. So finally, you combine these two together, you would get 7 over 3 smaller or equals to x smaller or equals to 3. So this is what I call the first method, whereby you use the definitions over here to solve the inequality by algebraic method. So in the previous discussion, we also discussed that you can also try to square both sides. So for instance, over here you square both sides and then solve the quadratic equation and then find the solution. So the second method, we will also try to do it here, and we will show that you get the same results. So you have modulus 2x minus 5 smaller or equals to x minus 2. So you square both sides. So you will have 2x minus 5 square smaller or equals to x minus 2 square. So then you have 4x square minus 20x plus 25 smaller equals to x square minus 4x plus 4. So you simplify everything, you get 3x square minus 16x plus 21 and factorize it. So I've done this beforehand, so I know what are the factors. So then from here, draw the number line. You have 7 over 3. This will be 3. So then it is with equal sign, so you draw the solid circle. So finally, it has to be smaller than 0. Therefore, your inequality is actually 7 over 3. X 3. Okay. So let's look at a second example. Modulus 3x minus 5, 2 minus x. So in this case, it doesn't make sense for you to use the first algebraic method over here. It doesn't really make sense for you to use these two identity. So what you can do is to square both sides. So you have 3x minus 5 square for 2 minus x square. So you have 9x square minus 30x plus 25 smaller than 4 times 4 minus 4x plus x square. Simplify everything, you should get 5x square minus 14x plus 9 smaller than 0. So same thing, draw the number line. Sorry, the factor will be 5x minus 9, x minus 1 smaller than 0. So you would have 1 over here, 9 over 5 over here, and then this time there is no equal sign, so draw a circle. So what you have is between 1 to 9 over 5. So essentially that's how you solve the inequalities involving modulus function. That's all for this particular video. Thank you.